Alrighty, so in this video we're going to learn how to identify parts of algebraic expressions. So we're just going to read through and then we'll look at the actual naming down here. So an expression is a number sentence without an equal sign. So we can see that down here, 4x minus 7. Each part of an expression is called a term. So if we look down here, that would be 4x and 7. We can see that they're circled in green, and I know on your papers it may not be in green, sorry. A lot of the time we get it printed in black and white at the centers, but term would go in here. That is what they're referring to by pointing at the circles. So each one, and we can have more than two. We can have, 3, 4, 5, 6, 10 terms. It just depends on how many pieces there are in the expression. The variable is the symbol that we use. Basically, it's used to hold the place of an unknown number. That's what the point of the variable is. And so we can see down here, here's the letter that we're using, and it's a symbol, but it's a letter. Usually we use something A through Z. The only thing I would suggest not using would be O, because it looks just like a 0, or lowercase l, because it kind of looks like a 1. So just be careful about that. But really, symbol means I could use at, or question mark, or anything that I would like to use. You could use a star. You don't have to use letters. It's just more common to see that in algebra. But when we do start doing these things, it's actually the younger students that do this. We would use more like cutesy symbols, just because it's something easy to wrap your head around rather than a letter. But we can see that it's pointing at the x here, so this is our variable. And honestly, when I'm doing this in class, I actually like using like a question mark, because that's what it is. We don't know what it is. It's a question. So the coefficient is the number with the variable. So whenever we have a number in front of a variable, that's called its coefficient. Basically, it's telling us how many of those variables do we have. So in this case, I have 4 x's. It's 4 times x. So this is my coefficient. All right. And then the constant is the number without the variable. So constant, meaning that it's not changing. We know what it is. I don't have to figure out how many of something I have. I just have 7. So this is a constant. So it's not being multiplied or divided by anything. It's just a number. All right. So those are kind of the basic pieces here. The only thing that it doesn't mention up here is this is what they call the operator. Operator. And that's just saying, are we adding? Are we subtracting? What are we doing in our expression? All right, so now we're going to look at what's called like terms and factors. So like terms, all the terms in expression represent numbers. So we just talked about that. Some are constant and some are being multiplied. Again, we just talked about that, right? 4x was being multiplied, 4 and x, and 7 was constant because it wasn't being multiplied or divided by anything. Numbers that are alike have the same operation, can be combined. So if we look at this group down here, how could we group these items? Well, I noticed that they're all fruit, right? So I could probably group them by type of fruit, right? Something like that. That would be very easy. I can see how many apples I have. I can see how many grapes I have. I can see how many watermelons I have. So this is the same for all variables. Constants are numbers that are not being multiplied, such as 3 or 57. So same idea that we were just looking at that with just the number 7. Variables have to be the same letter to be like terms. I should probably correct that little typo there, because variables do not all have to be the same letter. To be like terms, they have to be the same letter or symbol. Different letters represent different numbers. Also, the variables have to have the same exponent, because exponents represent repeated multiplication. All right, so now we're going to replace these items up above here with variables and combine the like terms. So instead of a picture of an apple, I'm going to put A for apple, A for apple. I'll put G for grapes, A for apple again, G for grapes again, and W for watermelon. So now I've just replaced these symbols with letter symbols, right? They're still symbols. They're still standing for something else. So now I'm just going to combine. How many apples do I have? Well, I have 3 of them. How many grapes do I have? Well, I have 2 of them. And how many watermelons do I have? I only had 1. Right? So this is just the kind of basic idea of like terms, is that if it's the same, I can add. And if I don't see anything in front of it, it means I have 1 of them. Okay, so this is a very basic one. We're usually going to see something more like, 3a plus a instead of just a plus a plus a. So then I have to go, well, I have 3 here and I have 1 here, so that would be 4a. So that's the idea of like terms there, is that you're just identifying ones that are the same. And when I say they have to be the same exponent, so when we get more into exponents here, if I had 3a plus, say, a squared, well, those are not the same anymore. Now I have just 3a's, and now I have a squared. I'm not really sure in this example how I could square an apple, but so that doesn't necessarily work in my fruit example here, because I'm not really sure how you do apple times apple. But that's the idea. That's what that means when I see a squared. It means a times a. Not a times 2. That's a big mistake that I see with exponents. So just be careful. This means I can't combine these because there's more a's here than here. Okay, so that's what I meant by that. Oh, I can leave that. I'm not really sure I was erasing it. All right, so let's look at factors. So factors, when a number or variable is common in all the terms or by grouping certain terms, we can factor. And this means that we are dividing this common number and or variable away from all the terms. So here's an example. Using the fruit from above, now we have 3 apples, 6 grapes, and 9 watermelons. So let's go ahead and write that down. 3 apples, 6 grapes, and 9 watermelons. So here's my new expression. We ended up with some more fruit here. Each of these terms can be divided by 3. So 3 is a factor. We place the factor in front of the expression with parentheses around it to signify multiplication will be necessary to kind of unfactor it. Because we're going to divide it away from each term, but it doesn't just disappear, that 3 that can divide away from each one. We put it in front to show that we divided it away. And in order to undo that division, it would require multiplication. That is exactly what these parentheses signify. Okay? So 3a divided by 3 would just be a, because 3 divided by 3 cancels out. It becomes 1. 6g divided by 3, well, I can't divide g by 3, but I can the 6, so we're only focusing on the coefficient. So 6 divided by 3 would be 2g, and then 9w, 9 divided by 3 would be 3, and then the w comes with it. So this is the idea of factoring, and we're going to practice this a whole lot more going forward. This is just kind of a basic idea so that you can see what it means when it says what a factor is. All right, so let's go ahead and take a look at this problem here. So we have a couple examples. So we have consider the following expression, 3x plus 5y plus 7 plus 8y. Select all of the true statements below. So 3x is a coefficient. Well, 3 is a coefficient. So 3x is not a coefficient, so that's incorrect. 3x is a term. Well, 3x is a term, 5y is a term, 7 is a term, and 8y is a term. So that is true. It is one of the 4 terms. 3x is a factor. Well, in order for that to be true, I'd need to be able to divide 3 and x out of each one of these terms. Well, I can only do that out of the very first one. This is the only one that has a 3 and an x, and none of these other ones can even divide by 3. And none of the other terms have an x. So remember, to be a factor, it means that everything can be divided by that number. So that's not true. 7 is a constant. Well, this is the only number that doesn't have a variable. So it's just a number. It's not being multiplied or divided. That is the definition of a constant. 5y and 8y are like terms. Well, I have 5y and I have 8y's. I could combine those. So I'd have 13y. So that is true because they both have the same variable. And none of these are true. Well, we just checked 3 of the boxes, so that means that at least 3 of them are true. All right, if we look over here, 8b is a coefficient. So again, that's kind of that same problem as that first one. 8 is a coefficient, but not 8b. B would not be included in that definition, only the 8. So I could say 8 is a coefficient, 5 is a coefficient, or 7 is a coefficient, but not the whole term. You wouldn't include the variable in that. 5a and 7a are like terms. Again, they have the same variable. I could very well combine them and say that I have 12a. 8b is a term. Again, we have 4 terms. So 8b is one of those terms. Sorry, you can hear a phone ringing in the background there. 8b is a factor. Again, same problem as that 2x that was over here, I think. It's either 2 or 3x. Oh, it was 3x because it was that first one. I cannot divide 8b away from each one of the terms. I can only divide it away from the very first one. So that is not a factor of the whole expression. And 3 is a constant. Okay, that is true because it is the only one there without a variable. And then none of the above. As long as I checked some of these, it is not going to be none of the above. All right, so that is identifying parts in algebraic expressions. Go ahead and jump on Alex and give it a try.